Here we're asked to first of all, find the derivative function of a linear equation, and then to evaluate the slope at 3 different points. So recall that f prime of x simply means that we need to find the slope function, or the slope equation. In order to do that, we have to use our limit definition. Now you're probably just saying, well, of course, the derivative here in this case, or the slope function, is just going to be a constant. And the answer is yes. This is mainly just for the algebraic practice. But let's just go ahead and run through it. So we want to find the slope between 2 points that are h units apart horizontally, x plus h minus x. And this really just means that if we have a function that we're going to find the slope between this point and another point, and if this is x, then this point right here is going to be x plus h. Not x minus h, we want to do plus h, and then h itself could be a negative number indicating the points on the left hand side. So we really want this gap, this h distance between these 2 points, to really approach 0. And so we specify that out here with this little reminder, and we call the slope as h approaches 0, we call that the limiting slope. So we want the limiting slope as the horizontal distance between the 2 points goes to 0. Okay, so we'll write down a few details. We already know f of x, that's an easy one. That's just going to be the function that we have, 17.1 x plus, or excuse me, minus 23. And then f of x plus h, well, that asks us to replace x with x plus h. So anywhere I see an x, I'm going to replace it with an x plus h. So there's an x plus h, minus 23. And I will go ahead and distribute 17.1x plus 17.1h minus 23. And now that's about as far as I can take it. I can't combine like terms, so now I'll go ahead and plug it into my slope formula here. So this will give me my little reminder here that I'm going to need to eventually plug in 0. 17.1x plus 17.1h minus 23 on top. That's this piece here. And now I'm going to replace f of x with minus 17.1x minus 23. You've got to be real careful to make sure to put parentheses around this quantity here, because we're subtracting it away. So we're going to want to make sure to change the signs on the 17.1x and the negative 23. And that's all over. Well, the x's go away, so we just have h. And now we see that if we went ahead and distributed the negative, I'll just write this right above, we'd have this plus 23. And I see that that cancels with this guy. The negative 23 cancels with the positive 23. And what I'm left with is the limiting slope as h goes to 0 of 17.1h over h. Well, those just automatically cancel out. Nothing really to factor out here. And I'm just left with the reminder to plug in 0 for h. But I'm left with a slope. Now remember, every one of these quantities is a slope. We start off with a true definition of a slope, and then we progressively work our way to some modification of that slope. And now we have a slope which is constant. So if you prefer, if you're like, well, I don't know where to plug in h equals 0, you could write 17.1 plus 0h if you want. And now, okay, well, let me plug in 0 for h. We see that it doesn't matter that h is there. Plugging in 0 for h is still leaving 17.1. So this is constant. This means that f prime of x, meaning the slope function, the slope equation, is the constant 17.1. So it doesn't matter which value of x you're talking about. F prime of, we wanted to know, of 0, 10, and 20 is 17.1. For 10 and 20, it's also the same thing because we have a function that has a constant rate of change.